All right, so let's do 1652. So a bullet with a mass of 3.6 grams is moving horizontally with a velocity v, which looks like it's not given, and strikes a 5 kilograms wood block, so MW, M sub B. Okay, block becoming embedded into it. So what does that mean? What would be the impact? What type of impact would that be? We just say you have elastics and plastic. So will be the one that basically this inelastic will be the one that just bounce back, no? The one that would be, sorry, the elastic would be the one that bounce back. The inelastic or the plastic would be the one that is just absorbed by the other body, no? Okay. So if you want, this will be inelastic or plastic, whatever you want, the bullet is going to go inside. After impact, the bullet and block slide 24. Oh, so this is on the ground. So after impact, the block slides a distance d, let's say 24 millimeters across the floor. The coefficient of kinetic friction between the block and the floor is 0.4, determine the velocity. Interesting. Okay, so like always, what do we need to do? First step is always to do some type of body diagram, okay? So here we're gonna put like one figure will be before impact. And let's say the one will be here. After impact, no? So this will be M bullet, V bullet, M wood, and let's say V wood. This would be now what? M wood plus M bullet. And this would be, let's say, just V, okay? All right, so also over here, since they give us the friction, I mean, you're gonna have here the weight. If you want to look at it, you're gonna have the weight, M wood. All right, let me just don't put the weight, okay? Just gonna confuse everything. Just put here, you're gonna have, sorry, on this one, you're gonna have the friction force, which is gonna be equal to what? Mu sub n, okay? Don't put anything on the first one. Okay, so 2 will be, so what type of motion are the bullet and the block having? Translation, so we can say using linear momentum. I mean, I'm going to do a quick derivation, but basically, make sure we finish. The equation for just translation for momentum was equal to what? Summation of moments, summation of forces dt, which is the impulse, equal to mv final minus mv initial. Okay, so this is for translation. This, what type of equation is this one? This is a vector equation, no? Okay, so if we apply this equation into the x direction, which I think is what they did here. Okay, I'm pretty sure. Yeah. Now you see they do work and energy. They do work and energy as well. All right, let's not look at this because I'd rather even if we get something. Okay, so let's say we use this equation, okay? All right, so let's start by the right hand side. So on the right hand side, what should be the equation? Initially, what do you have? And bullet, the bullet, no? And then at the end, what do we have? Plus mass of the bullet. And I call this one here V, no? V combined. But this is not zero. In here initially is zero, but this is now you have the friction force on the x direction.
But it doesn't say that it slides 24 millimeters. That kind of implies that it's stopped, doesn't it?
Yeah, so you have an amount of time. Let's do it differently. Okay, I'm trying to do it. I don't agree with the way they do it. Okay, I will put this problem into a different chapter. But now, so what is the so here? What do we have? We have friction that will be F dt. No, what do we say was F? So it's going left would be minus mu sub k n times t equal to mb vb minus mw, so mass wood plus mass by v. So they didn't give us any velocity, no, on the problem. Okay, so that's why it's getting. Okay, so I would say that's my equation one. What can I say? See, we started from a simple problems that I thought, but now it's
You have to be looking into it.
let me read the problem again. Yeah, I can find a relation between this V and the distance and the time. So I can factor out, but I still would not know the time. or the velocity of the bullets? Yeah, but it's fine. That's what we need to solve, no?
We have to, looking for the initial velocity of the bullets.
No, the velocity of the, we need to find the velocity of the bullet. Oh,
Yeah.
okay, okay, well, the one of the blocks.
That's why,
And they never mentioned that this is going to come to a stop after 24 millimeters.
they kind of quiet, but it's.
Yeah. All right, so we have this equation. I don't know. We're gonna keep going, see if we get someone. Now, using work and energy, I don't see any other way. I mean, so for translation, what should be the equation? Summation of forces dr or ds would be equal to 1/2 mv final square minus 1/2 mv initial square. So for the block, and bullets, what we're gonna have? We're gonna have summation of forces dr. So the initial will be 0. And then we have here 1/2 and bullet plus wood. This one I call it V square. Okay, and what is the force doing work? The friction force. The friction force is minus mu sub k n times d will be equal to 1/2. Okay, so now we got it. M sub b plus, what did I put? Sorry, mw here, so not paying attention, mw d square. Ah, okay. Now I see what they've done. Yeah, I see what they've done now. Okay. All right, so I apologize because I think it's going to get confusing a bit, but so what they have done really is that you start with this, okay, using the work energy, which is what was my first intuition. Okay, so now from this equation, what can we solve? Correct. So from the above equation, you can solve that, let's say v square will be equal to 2 mu sub k. Oh, and now we need to do what n is, n d divided by m sub b plus m wood. Okay, what is n? Yeah, so basically would be what? Mass of the block, mass of the wood, times G, no? Sorry for that, it's not going to be a good example today, Charlie. So you're gonna have this going to be equal to what? 2 mu sub k. If you want to put it here, m sub b plus m sub wood gt divided by m sub b plus m sub wood. So v squared is going to be equal to 2 mu sub k gd. Or v equals to square root of 2 mu sub k gd. Okay, so now here is the part that I like this problem 4. So so over here, what does that mean? What it means is that using the principle of work and energy, we already took into consideration the effect of the friction force. Correct? Okay. So what they have done in the solution, I don't like this problem, is that now let's say I'm going to go back. So basically, I'm changing everything. All right. So next, so using the principle of impulse and momentum. So we go back to the first problem that we did, which is going to be changed now. So we have the bullet. The block needs to be equal to the block plus the bullet. So again, before and after. Okay, so once again, we have the equation summation of forces dt equal to mv final minus mv initial. So what is happening over here is that here is true that you still have the friction force. Correct? But in this problem, what do we know? We know the final velocity. And we know the final velocity in function of what? Of the friction force. So basically that means that when we're calculating this with velocity, we already consider the friction force. Does that make sense or no? Okay, sorry, I know I didn't do a good job solving this problem. So basically what happened is that out of this equation, you're just going to get mv initial will be equal to mv final. So that now what we're going to have is the same equation we had before, is just mb v bullet will be equal to m bullet plus m wood times v. Where v is the value we just calculated, 2 mu sub k gd. So from this equation, we have velocity of the bullet will be equal to m of the bullet plus m of the wood, square root of 2 mu sub k gd divided by the mass of the bullet. Okay, sorry for the confusion on the start of the solution, okay, of this problem. So let's check if this is really what I did or not. So numerical application. I hope we're gonna get the same thing. What do we get? Mass of the bullet is, oh, now we need to be careful. So 3.6, how many kilograms is that? All right, so 1,000 plus 5 times 2 times 0.4. G will be 9.8, 1 if you want, and D will be 24 10 to the minus 3 gravity meters. And all this stuff divided by 3.6 10 to the negative 3. How much? 603? 603. The answer makes sense. So I think that's at the end what they did. Let's check, but hopefully it's what they did. Okay. Otherwise, yeah, otherwise I will be completely lost. Okay. Yeah, I don't like this problem, okay? Because it mixes two principles, okay? I mean, I think for today I'm going to stop here. So, guys, please, what about doing something? What about next lecture on Thursday? You come with any question you might have about the exam. Okay, and we do like a review class.
You think I can get the notes?